Before we get started, I just want to again issue that basic disclaimer that this project is funded by the National Science Foundation. We're very, very grateful for that ongoing funding, but this work does not reflect the views of the NSF. All right, and for those of you who are joining us for the first time today, I just want to briefly introduce the team again. And so I am Dr. Amber Crowell. I'm a professor of sociology here at Fresno State and the director and principal investigator of the Mark Fawcett Lab. We also have here with us Dr. Jalefka, and so I'm just going to ask her to say hello really quick.
Hi, everybody. Good morning. I am graduating with my doctorate in sociology at Texas A&M in like a week. Woohoo!
Yeah. Yes, it's super awesome. Texas A&M is also where I did my doctorate under my mentor and longtime collaborator, Dr. Mark Fawcett, who I actually started this project with and passed away a couple of years ago. And that is why we are called the Mark Fawcett Lab in his honor. I also want to ask Brenda to say hello. So Brenda, if you want to say hi real quick.
Hi, everyone. My name is Brenda. I am an undergraduate student at Fresno State. I'm pursuing anthropology and city and regional planning and certificates in environmental planning and GIS. Thank you.
All right. Brenda is part of our student team here at Fresno State. And Patricia's on the call. She was traveling earlier in the week. I'm not sure if she's able to speak now. Patricia, are you able to say hello?
Yes, hello. I just got back extremely late last night from Missouri, so I'm catching up on Pacific time. But my name is Patricia, and I'm a graduate student at Fresno State. I'm in interdisciplinary studies, focusing in bioarchaeology and federal Indian law.
All right, thanks, Patricia. Another awesome part of our team here at Fresno State. And then I also just want to recognize Megan Bodley, who is actually not part of our team anymore, but her work when she was with us is a lot of the reason why you have these incredible resources available through our site. She was our project manager for a little over a year. She's a graduate student at Texas A&M. She's a PhD candidate at Texas A&M, working on her dissertation. So we are going to just briefly going to again sort of describe our purpose at the Mark Fawcett Lab. I study residential segregation, and so the primary purpose of the project is to map and understand residential segregation patterns in urban areas in 1940. But more broadly, and the reason why we have this wonderful support from the National Science Foundation, one of our goals is to share what we're learning and share our resources with other institutions, with other communities. So that way we are building research capacity beyond our own project. And so everything we do is meant to be low barrier. We use open source software. All of our training materials, all of our resources are shared publicly. And so that is, that's really what we're all about. It's the reason why we are offering these trainings this week. So today we're going to be going, like I said, into more of the practical, how do you use GIS software? And we're going to be working through examples using the 1940 historical data. And so there will be some aspects of how do you actually read those archival documents and how do you digitize them into maps and QGIS. But again, those fundamental skills are applicable to anything you want to do with GIS. It could be Harry was talking about learning back in the day about all the different applications of ArcGIS, and it was everything from mapping the location of foxes along a freeway to where to build roads in Los Banos. So GIS is applicable in so many situations. And so we hope, if nothing else, you walk away with enough to think about how you want to use this tool. So we'll go over the fundamentals of GIS, and for those of you who already use GIS, this will not be anything new to you, but this was meant to be a very beginner-friendly training, and so just bear with us through that part. And then we will get you started in QGIS, the actual software environment, and talk about how to set up your project, and then we'll go into a demonstration of a few different types of situations you'll find yourself in when you're specifically mapping those historical neighborhoods. And then we'll, with any time we have left, we'll talk a little bit about troubleshooting. Okay, so some opening comments. I have some, and then I'm also gonna call in my colleagues here to share any thoughts that they have or any tips or strategies they have before we get started. First, I say embrace your status as a beginner, if that's what you are. We all were beginners in using GIS at one point. We all, to some extent, had to teach ourselves how to use this software and know where to go to find help. And so just kind of embrace that. It is a learning curve, but it's a very satisfying one because in the end, you do have these skills and you know what you're doing, and it's a lot of fun. Also anticipate and enjoy the problem solving, especially when you're mapping historical geographies. The answers aren't always going to be there, and the materials aren't always going to be where you're hoping they will be. And so you're going to have to rely on detective skills, other resources, and make some decisions that may just require documentation saying there was nothing more I could do here. And so this is the decision I made. And so expect that too. It's not going to be a clean and perfect process. But you will, learn to appreciate your problem solving skills. And then to that point, make sure you document your process. So whatever decisions you make along the way, make sure you are documenting them. So that way, as your project builds out, you are standardizing your procedures, and you can also explain to others, why you did what you did. From a researcher standpoint, these are all good things to bear in mind. And then they're also good skills if you're an instructor and you're with us today. These are good skills to instill in your students, right? This sort of learning to be comfortable with the discomfort of not knowing what you're doing right away, of not always having the answers right away, and then of always documenting your learning process. Those are things that, of course, we want our students to get in the habit of doing and thinking about. Okay, I want to ask Brenda and Patricia. I didn't warn you I was going to do this, so it's okay if you need a little more time. And also Dr. Jalefka, are there any other strategies, tips you want to share based on what we went over on Tuesday, or just jumping into this next part?
I can start. Hi all, my name is Brenda. I'm an undergraduate student at Fresno State. Just really want to reiterate, as a student, I've taken all of the GIS courses offered at Fresno State, and it has been the most impactful in this project and other projects when our fearless leader, our professors also say, I'm a beginner too, because these softwares, ArcGIS Pro or QGIS or QGIS, they're rapidly evolving software. So you might learn how to use it in the next 2 months, and then there's going to be an update, or there's going to be a new tool or a new analysis rendition, and you'll have to learn it again. So building a classroom culture where it's okay to ask questions, there's time for it, to debrief, to troubleshoot together, and then share if like a particular student runs into an issue, kind of making that available or going over it together. And then making sure that students have all the tools that they need. So if you notice that if it's a classroom project and all of your students have MacBooks, getting familiar with that with QGIS on a MacBook, they probably will need access to a mouse because the trackpad can be difficult to make polygons. And I like to use an iPad and an Apple Pencil and the program Procreate, where I can go in and like really move the maps around and not have to be on a trackpad on like Paint, like on Word, or like more or software that might be difficult or more time consuming. So thinking about what tools might students need to complete the project successfully. And I'll pass it to whoever's ready.
Yeah, on the last note on the slide about document your process, one thing that I've been utilizing more this past year was a Google Sheets that was already made by Megan. That helped out a lot to kind of log in which one I was working on, which polygon, and also writing down the microfilm, like the numbers to refer back to. Those are just really key things to kind of keep yourself using so that you know where exactly you left off. Because if you do take some time off and then you come back and you're trying to figure out like, what was the last thing I did? And you don't know. And it's just something nice to refer back to. So that was a great help.
I have nothing additional to add. All of these are like very good points. I guess I'll just echo that if you view this process as a puzzle that is, challenging and fun to solve, it is enjoyable to do this work. And, again, whether you do historical GIS or you find a different way to apply this, it can be fun being creative, thinking of ways to apply this to your research interests specifically.
All right, thank you, all three of you. Yeah, so you can see that we're all kind of echoing each other on sort of like what's the best mindset and best habits to get into as you get started. All right. So let's go over some fundamentals of GIS, just some concepts, definitions, things you need to know. If you have no idea what GIS is, right, this is for you as well. So GIS, it stands for Geographic Information System. It's a computer-based tool for defining, storing, analyzing, and visualizing geographic information. It is truly wizardry. It is an incredible tool that allows you to digitally work with geographies, and the possibilities of what you can do with it are endless. You can, this graphic is really helpful because what it allows you to do is take spatial data, like think of like the latitude and longitude of a geography, and connect that to any other data you have that might be spatially defined. It could be demographics. It could be, in my case, I want to know where different racial and ethnic groups live, where different age groups live, where different types of households live. And so for me, being able to connect that demographic data that comes from the census to geographies and visualize that spatially is really, really important for the work that I do. But it could be anything. It's also very popular in public health research. So, here in Fresno, we have some of the worst air pollution in the country. And so there's a lot of interest in mapping where are the highest rates of asthma, of cardiovascular disease that are connected to exposure to pollution. And you may even, if you've never experienced any sort of other GIS work, you're probably, I think the most popular application of GIS is after elections, when you see those county map results of how people voted, or sometimes you can even, the New York Times does this, lets you go down to a very fine geographic scale and see who did people vote for in your neighborhood. Those are always really popular tools that come out after elections. That's GIS, allowing you to interact with spatial data and spatially defined data like election results. And so you have been exposed to GIS at some point in time. Okay, within GIS, it's also important to know about projections. You probably learned about this in your grade school geography classes, the different ways that maps get projected. And here's the problem with any map, is that the Earth is round, right? And so when we're looking at geography on a flat space, there are different ways to project that geography. And it's important to know which projection you are using. In GIS, this is very true and very important, because you have some choices to make here about how you want that spatial data to be projected, and you need to be consistent with how you are projecting that data. So we use what are called a coordinate reference system. There are many different coordinates reference systems. We call it the CRS. I will tell you which one we prefer to use. We mentioned this briefly on Tuesday, but it is a distortion that allows you to take any geographic area, any map, and display it in 2D in a 2D environment. So for a computer screen, you need a good CRS to be able to view that map and keep it in the right place. So here's some of the more popular CRSs, projections that you'll see used. The one that we use is 3857. It's very popular with web-based projections, with web-based systems. Google Maps uses it, ArcGIS Online uses it, and so we use it because we publish all of our products on ArcGIS Online, so that way you can interact with them and play with them on your phone or in a web browser. So this is what we prefer to use, but there are other ones that you'll see used as well. 4269 is used by most federal agencies, but you will see me using 3857. Okay, another definition you need to be aware of when you're using GIS is this concept of features. So features, there's different types of features that go into what we call a shapefile. One is the geometry itself, right? So the shape, the boundaries of it doesn't necessarily have to be a polygon, but we're talking basically about the shape here. And then there's a spatial definition, which tells you where that shape is located. So it's tied to specific real locations in the real world. And then you have your attributes. And so these are, if you picture a data set that has all that information in rows and columns, those are your attributes. So for each element in your shapefile, there's data that goes with it. And so you have those attributes. There's different types of geometry you could work with in GIS. You could be working with points. And so here you have an example. If you use like Waze, or I think even Google Maps does this now, it'll display, you know, where things are happening along a freeway. That's point data, right? It's telling you exactly where something is. You also have lines, right? Which you'll see used in weather forecasting, for example, or if you're plotting a route, right? Another popular application in GPS, sorry, my acronyms are getting all mixed up, in GPS applications. And then for us, this is what we're going to be working with are polygons. So these are actual shapes that we're mapping the boundaries around. You can have single polygons. So if you're looking at the contiguous United States, right, this is just one polygon all connected to itself. You can also have multi-polygons. And so the United States, as we know, is not contiguous. We have states that are not connected to the main geography of the United States. You have Alaska and Hawaii, but they are all the same polygon for GIS purposes. They all share the same attribute that it is the United States. And so that is a multi-polygon situation. With enumeration districts, you'll run into this issue. So you'll have a single polygon. So here on the left, Dr. Jalefka, where is this? Is this Houston?
Yeah,
These
they're
are
both Houston.
They're both Houston. So here in Houston, you have some enumeration districts where, for instance, 63 is just one single shape, right? There's no other part of it floating anywhere else. So that's just a single polygon. But also in Houston, you have these little land masses out in the water that they are all, the census defined them as the same enumeration district. They are all enumeration district 41. And so GIS allows you to define these polygons as all being part of the same element, as all being part of the same shape, but they are not connected to each other. And so there is a way to make sure that at least in the attribute table, it is all together. Okay, and then here's a sort of what can go wrong if you're not paying attention to your coordinate reference system. So here on the left is an example of a shapefile that was created for New Orleans, where something went wrong along the way with defining the CRS. Maybe they did not consistently use the same CRS. And so what happens when that shapefile that was created gets overlaid on a base map, and by a base map, I mean this could be Google Maps, this could be OpenStreetMap, is that it's not quite lining up with the geographic points of New Orleans. So you can see it's kind of slid off. So when I was talking to Dr. Jalefka about this, she gave a really good example of thinking about tracing paper. And this idea of when you're tracing over a shape on tracing paper, you run the risk of that tracing paper slipping, right, as you're working. And then it's not quite in the right place anymore, and you don't get the shape quite right. So a CRS ensures that that trace paper sticks. So that way it doesn't move away from where it's supposed to be. So if you think about it that way, this is an example of the CRS wasn't properly defined. It may have gotten changed along the way. So the tracing paper slipped, and now it's not aligned with where it needs to be. On the right, you see Manhattan, New York. And what's going on here is the CRS was just never defined. And so what happened with this project is they drew the polygons, but they're not tied to a real geographic location. So a GIS software will just by default put it at latitude and longitude 0, which will pitch you right off here off the coast of Africa. And so this is Manhattan floating out in the middle of the ocean, right? And so you need that CRS so that way it is tied to actual geographic locations, right down to, you know, the lines that you draw. You want them to, no matter where you're applying that shape, to show up on the right streets in the right places. You don't want it floating off in the ocean or, sliding off the map. All right. So in QGIS, and I'm about to take us into that environment, but just some things you should know before we load up the software. You have what's called a QGIS project. Now, the project basically saves the settings of your instance of QGIS. So this includes any tools that you have loaded up, any plugins that you've decided to use, the CRS you chose to use. So any of those settings get saved, and any layers, and I'll tell you in just a minute what layers are, any layers that you added to your project will get saved so that when you load that project up again, everything, your entire workspace is exactly as you left it. So that is different from the boundary file. The boundary file is within the project. It also saves other settings like the symbology that you're using. So the colors you choose to use, any labels you apply, any data that you choose to map. So layers in QGIS, you can think of them, I like to think of, so in grade school, my teachers used overhead projectors and transparencies. And I think a lot of people in this space probably remember those too. My kids now, their teachers use these like fancy iPad things. And so overhead projectors are not a thing anymore, I think. But back in the day, you had those transparencies that you could layer, right? To add on new elements that you could then remove if you want to, or put them back. So that's basically what we're doing in QGIS when we're talking about layers. They are layers of data that you can put on top of each other in whatever order you want so that it displays with data underneath, data on top. And so when we get into QGIS, you'll see what that actually looks like. So there are external files you can add, so shape files you can bring in. QGIS also has hosted layers. So if you want to have OpenStreetMaps, which is basically the open source of, you can think of Google Maps. That's a layer that you can add in through QGIS. So that way you know where in space you are. And then vector files are the shape files, those actual boundary files that you are creating. But you can also bring in ones that have already been created. All right, so a shapefile itself, which is what we will be making, it actually is a collection of files that all need to be together. So they define the different features and data that goes into that vector file. So you have the geometry file itself, which is where the points or the lines or polygons are stored. You have an index of the features, your database of attribute data, which is basically it's like a CSV file. It has all the data in rows and columns that goes with the geometry. You have your projection info file, and then you have your character encoding. All of these files need to be together in the same folder, or you're going to be missing a piece and the shapefile will not function properly. And so on Tuesday, we talked about, setting up your workspace, setting up your folders, your work folders. One of the folders that we encourage you to set up is one that is just for your shapefile. And in that shapefile, you should have all of these files together. Now, when you start working in QGIS and you go to save your work, all of those files will be saved together already. And so your job is to just not move them. Don't separate them from each other. Do nothing and everything will be fine. So these will all be saved together with the same name, and that's how QGIS recognizes that these are supposed to go together. Okay, so they just all need to be in the same place. And then this QGZ is that project file, the one that saves your working environment in QGIS. All right, I am not going to go through the whole process of installing QGIS. I already have it installed, but if you have not had a chance to install it, just some notes here. We've said this in the emails too, but just to reiterate, you want to download the long-term release. So that is the most stable version of QGIS. It's the one where they're not putting out new versions with things that they're testing out. So if you don't want to deal with glitches and bugs and those sorts of things, stick with the long-term release. The link is, I believe, in the chat, or will be soon. Thank you, Brenda. And I think I'm going to ask Dr. Jalewka actually to talk about this real quick. I'm not a Mac user, but she is. And so for all Mac things, she is the person to talk to. So do you want to just explain this issue real quick?
Sure. Yeah, it's just the Mac firewall thinks like, what is this QGIS thing that you're trying to install? I don't trust it. It's from the internet, and you have to just tell your computer it's okay. And it's a little bit more involved than just like clicking in a box and saying like it's all right. You do have to go into your applications folder and manually, say like it's the same as on a Windows setting, you would say run as administrator or something like that. It's not hard, but it's just a couple more steps that you have to go through. Once you do it the first time, you never have to do it again, though.
Great, thank you. And actually, Brenda, if you want to go ahead and, I don't know if you've done it already, but do you want to go ahead and share the slides? So before we go any further, what's nice about these slides, which Dr. Jalefka put together for us, is that they have screenshots using the Mac version of QGIS. And so if you are a Mac user, it's not radically different from the Windows version, but there are things that are just in different places. And then there is this weird issue with getting QGIS installed on a Mac operating system. So the slides are really helpful for Mac users to see what it looks like for you, because it's not going to look exactly the same. I'm on a Windows operating system. All right, did we get those dropped in the chat?
Yes.
Thank you so much. All right, so now I am going to switch my screen and not be sharing slides for most of the rest of this, because actually, instead of switching, I think I should just move this over. Hold on. I'm just gonna move this over like this. There we go. Okay. Is QGIS up on the screen? Perfect. All right, so I'm gonna start actually by showing you what the end goal is. So what you're looking at here is a shapefile of enumeration districts in Minneapolis and St. Paul in 1940. And the first thing I'm going to point out is that you can't tell where this is, right? It looks like it's just floating in space, but it actually isn't, because QGIS has geo-referenced everything that I drew in here. I have my coordinate reference system here. You can see 3857. So as I was drawing, it knew exactly in actual geographic space those shapes go. And just to demonstrate, I'm going to put on the OpenStreetMap layer. And it always drops on top. And so I'm just going to rearrange it, put it underneath. And you can see there we are in Minneapolis, right? So it's actually not floating in space. If I turn that off, right, there we are in Minneapolis and St. Paul. So that is part of the data that gets saved with the shapefile. The shapefile will always appear in Minneapolis and St. Paul, right on those streets that I map those boundaries along. All right, so that is our end goal. I'm actually going to clear all this out now. Just going to remove these layers. There we go. We're now in a blank space. Okay. 1 second here. I need to rearrange my screens. I'm multitasking between two apps, and so I don't want to be switching back and forth in front of you. Okay, so the first thing you want to do is start a new project. All right, well, actually, let's do our global preferences first. And if you have QGIS up in front of you, follow along as best you can. If you don't have QGIS up in front of you, or if you're just like, I can't do both right now, that's okay. You can always try this later, but I'm going to walk through step by step just for the record. So the first thing you want to do is make sure you have your global preferences set up. So one of the first things that we like to do is check our plugins. So up here in my top menu, and for you, I think it looks different in Mac where the plugins are. I'm going to go to Manage and Install Plugins. All right. So I already have the plugins that I like installed, but the two that I really prefer to keep are the Topology Checker and the Geometry Checker. These two are useful tools for later when I've finished drawing all my polygons and I want to make sure that I have drawn valid polygons. So there's no like gaps or overlaps or duplicate vertices, those kinds of issues that can just give you wacky geometry. You don't want those things to be in your final file. So those are the tools that I prefer to use. Are there any other plugins that any of y'all like, Dr. Dulefka or Brenda or Patricia? Yeah, these are pretty much it. There's some other ones here that are just on by default, but the geometry checker and the topology checker are the ones that we want to make sure we have. So you want to make sure those are installed. If they're not, you can search for them and install them. And then we want to specify our CRS. Now, mine is already specified, but I'm going to walk through how you would go about doing that and even setting it as your default if you want that to be what happens every time you open QGIS. So here I'm going to go to settings and go to options. And once again, it's different in Mac. I think you have to click on the name of the application up at the top to get to your preferences. But under options, I'm going to go to CRS and transformation and click on CRS handling. And this is where you can specify what your default coordinate reference system is. So mine is set to 3857. And then for my layers, I'm also saying I want that default CRS to be used for my layers as well. And and then I click the option to say use the default layer coordinate reference system. So this ensures that every time I open QGIS, my coordinate reference system is exactly what I want it to be. And I don't make the mistake of starting a project in the wrong coordinate reference system and then ending up with that, that tracing paper slipping off the map, right? You always want it to be referenced in the correct location. All right. Another thing you want to make sure, this is just, it will save you some grief down the road, is you want to make sure you have snapping turned on. So under map tools, I'm going to go to digitizing. Now, what is snapping? Snapping is a tool in QGIS that ensures that as you're drawing those neighborhoods next to each other, they're going to have lines and vertices, right? The points where the lines meet. And so let's say you draw one neighborhood and then you draw another one right next to it. Snapping makes sure that the vertices on the neighborhoods that are next to each other snap together. And so that will guarantee that you don't have any gaps or overlaps between the shapes. So that's really important to do. And you can make sure it's on by clicking on Enable Snapping by default. And we have a few preferences here. So we want to make sure it's snapping by vertex, so by those points, not necessarily by the lines. And we want the snapping tolerance to be set to 10 pixels. All right. And then finally, you can, I'm going to say okay here. Up here are all the, it's thinking. I'll let it think. Up here, you'll see all the tools. Right now, a lot of them are not turned on because I'm not in editing mode, but I'm about to show you what that looks like once we get a layer going. But just in the meantime, you want to make sure that you have all the toolbars that you're going to end up using. So under View and Toolbars, here are a few of the toolbars that we like to make sure are turned on. So the Advanced Digitizing toolbar, the digitizing toolbar, map navigation toolbar, which gives you the tools you need to move around your map. Your plugin toolbar, which will allow you to see the geometry validation tools. And then you also want your snapping and your vector toolbars turned on as well. Okay, and then I've got a few other things turned on. All right. So now we'll start a new project. Right, so I have a blank project here. If you don't have a blank project open, you can click on that little sheet of paper there. It'll start a new project for you, and you'll just have this blank space that just looks like this. And it doesn't look like anything's going on, but as you see me moving around, you'll notice down here in the little coordinate window that it is actually recognizing where in real space I am. So as I'm moving, the coordinates are changing. It's just there are no features on that geographic space. Okay. So the first thing I'm going to do is add the base map, just so it's not just a white space anymore, just so we know where we are. So what I did, I have my browser open under XYZ tiles. I just dragged OpenStreetMap down into the layers. You can also add it this way by going to Layer, Add Layer, and go to Add XYZ Layer. And OpenStreetMap is already loaded up for me. And I could just say add it that way. I'm not going to click it again because it'll just add it a second time. And because we haven't told it, we haven't specified where we're going yet, it's just it's showing the whole world. And this is actually a good chance to see how the world is being projected into 2D space. So this is what it looks like. All right, as you work, the base map layer is really helpful because you're going to be looking at those historical drawings of enumeration districts going along street boundaries. And a lot of those streets haven't changed for the most part. Sometimes they do, sometimes freeways get built, places get torn down, new developments emerge where there was nothing before. And so it's not always going to be reliable, but it'll save you a lot of time. When you're in these urban areas where usually the urban core at least is pretty similar to how it was in 1940. So it's helpful to have a street map like this underneath your work, just so you know where you are. So to create a new shapefile, which is our goal here, is to make a new shapefile, we want to go up to Layer, Create Layer, and New Shapefile Layer. And there are a few steps you need to take here to make sure that your workspace is being set up the way that you need it to be. So first, you want to give your file a name and tell it where it's going to be saved. So if you click on those little dots there, I'm putting it, here's my folder for Minneapolis. I'm going to be using Minneapolis as my example. I'm going to save the shapefile in the folder that I created. I just said SHP. That's the file extension for shapefile _1940. You can name it whatever you want. And I'm going to go ahead and give the whole thing a name. St. Paul, Minnesota, 1940. It's going to save it as a shapefile, but just know that it's also going to have those other files with it, the ones that we talked about that all need to be together. All right. So it knows where to save it and when it's going to be named. You also need to tell it what kind of geometry are you creating. We are making polygons. It should already have the CRS loaded up because I specified my default and what I want to use for my layers. So 3857 is specified here. If that's not there, then you want to click and make sure that that is what is loaded up for your coordinate reference system. And then the other thing that is just helpful to do right up front is go ahead and add your data fields. These are the data fields that, in addition to the data fields that say what the latitude and longitude is of those spatial attributes of your polygons, are any additional data fields you want to include that identify what is this area that you are drawing. So for us, we want data fields that include the enumeration district number, the prefix that says what area of the metro district is this enumeration district in. We also want the county FIPS so that when we add this map to the larger map of the United States, we know what state and county this enumeration district is located in. So, and any other data fields you want to include, any other identifiers you want to make sure are included as you're drawing each shape, this is where you can set them up. So you're basically, again, if you're thinking of a spreadsheet, this is where you're defining what those columns are going to be in the spreadsheet. So there are a few that we like to include in our projects, just for consistency's sake. We like to include the FIPS code. So that's that state FIPS code and the county FIPS code. And you can say how big that field should be, how many characters should be anticipated, right? We want to make sure it's a text field, first of all. And the FIPS code is only 5 digits. Oops. All right, and I'm going to add that there. I'm going to go ahead and remove this ID. This is just like a default field that they include, but I don't need it, so I'm going to remove that. We also want the enumeration district prefix. If you recall from Tuesday, within a metropolitan district, you will have usually a prefix for the central city and then another prefix for the area around the central city. And within those two types of areas, you might have an enumeration district 20, right? There will be a 20 in the central city and a 20 in the area outside of the central city. The prefix tells you whether that enumeration district 20 is here or there, right? So it's an important piece that uniquely identifies the enumeration district. So we call it ED pre. It only needs 4 spaces. And then we also, these are sort of just project specific preferences for us. ED main 2 is the actual enumeration district number. So if the enumeration district is 20, we would fill it in as 0, 0, 20. We put leading zeros on all of our identifiers. All right, so I'm going to add that one. And this is something that's going to come up as I'm working through some examples. Sometimes enumeration districts in 1940 are split up into parts. They're both enumeration district 20, but there's a part A and a part B. So we want to make sure there's a field for that just in case. That one only needs 2 spaces. And finally, there are some decisions we have to make along the way as we're working. Sometimes there's just no way to recover a boundary. It's just that the landscape of that particular area has just changed so dramatically, and there are no archival resources to perfectly recreate. So we want to have a notes field when we need to say this is an estimated boundary. Or sometimes within an enumeration district, there's a separate ED inside the enumeration district for, let's say, a mental health institution or a county jail. In residential segregation research, those sort of institutions are not needed because we're trying to understand residential patterns. So sometimes we will subsume those enumeration districts in the larger one, just because for our data, those geographies aren't even needed. And so that's where we would leave a note saying enumeration district 21 was subsumed by enumeration district 20. So we want a notes field and we want to give it some generous space. So we're gonna, whoops, leave that text. Gonna give it 254 characters. And this is enough just to get us started, right? As we draw each polygon, when you complete the polygon, the data field table will pop up and you can populate the information for that polygon. All right, so what just happened? I said, okay, there's now a new layer in my layers box here. You see that? And it's got the name that I gave it. It's gonna be orange as I draw. I may not want that color. So here are some other things you can do as you're working. I'm gonna right click on this new layer, which doesn't have any attribute, it doesn't have any polygons yet. And I'm gonna go to properties. So for a layer, there are a lot of things you can change about it. Ways that you can change the way that it's appearing on your screen. You can change the color that will be used for these shapes as you're drawing them for the polygons. So if you don't like the color orange, right, you can click on that and make it green if you want. But there's a specific hex code. There's like one color that's just your absolute favorite color. You can be very, very specific about what color you want to use. I found this very pretty color the other day that I'm gonna plug in here. Yeah, it's a very nice shade of blue. Other things that you might want to do, because at least in my case, and I think we all prefer to work this way, having that base map underneath of OpenStreetMaps is really helpful for figuring out where you're going and where those lines should be drawn. It's helpful to make your working layer a little transparent, so that way you can see OpenStreetMaps underneath it. So down here under layer rendering, you'll see opacity here. I'm going to knock that down to 70. All right. It doesn't look like I did anything because we haven't drawn anything for Minneapolis yet, but you'll see how those settings play out as we start drawing. There's one more thing I want to do, actually. I'm going to go to properties again. And one of the tabs here is called labels. I like to be able to see as I'm drawing if an enumeration district 200 is right next to enumeration district 50. I like to be able to see the enumeration district's numbers displayed on my screen, so that way I can just go and see, oh, there's 50. Okay, that's where I need to be. So you can have labels displayed based on some data that is in the attribute table. So I changed the label to single labels, and I'm going to ask it to display ED main 2, the enumeration district number. And you can change things about the font. You can make it bold. You can change the size, the style. I'm just going to leave it like that. Okay, so we've got, I am going to go through a few examples in the next, like, say 20, 25 minutes. And then we'll leave lots of time for question, reactions, those kinds of things. So just stick with me as we go through a few examples here. Okay, so one thing I want to point out is now that we've added a shapefile, there's now an editing. There's now the option to turn on editing. So this little pencil here, what I'm going to do is I'm going to make sure that the shapefile is highlighted so it knows which layer I want this to happen on. And I'm going to say edit. And all these tools lit up. All right. To get started, I want to show you right here. This tells me that snapping is turned on. See this little magnet icon? It's already highlighted, which means snapping is on. That's because in our settings, our global preferences, we said we want snapping to automatically be turned on. That way we don't forget to do it. It's just nice that it's already on for us. The main tools you're going to be using are here and here. So up here are your map navigation tools. When the hand is highlighted, it lets you move the map around. If you want to zoom in or out, if you have a mouse like me with a little scroll wheel, you could just scroll in and out. So I just scrolled in on my wheel. But if you don't have a wheel, if you are working with a touchpad, which is quite frankly very challenging, but it can be done, then another way you can zoom in and out is by using the magnifying glass tools. So if you want to zoom in, click on that. And I see St. Paul there that's lit up on the map. I'm going to click and drag. And it zoomed in a little closer. I'm going to do that again and again. And if you want to zoom out, you can just turn on that one instead. All right, so those are your navigation tools, the main ones you're going to want to be using. And then to get started with drawing a polygon, these little green blobs all represent the tools that let you draw and create polygons. And so the blob that has this little star next to it is what you want to turn on to start drawing. And you'll see there's now this little like sort of crosshairs icon for your cursor. I'm going to zoom all the way in. I'm actually going to turn this back on. And I'm going to take you to sort of the best case scenario first for drawing an enumeration district. So what I'm going to do now is I'm going to pull up this map here. This is a section of Minneapolis. And there's a few things I like here. One is that there's a very clear landmark that I can go looking for. Cemeteries tend to still be there. And so anytime you see a cemetery, it's kind of like, yes, okay, I know exactly where I am. So I'm going to be working in this area around Crystal Lake Cemetery. It's also right next to the Mississippi River. And so this is a very easy area to find. One thing that makes this particular example ideal is, first of all, the map is very crisp, right? In relative terms. And by that, what I mean is that I can see the numbers. I can see, if I zoom in real close, I can see the pencil outlines of the enumeration districts, right? And I can see the street names. It's not super easy to see, but compared to some of the other scans we have to deal with, this is pretty good, right? I can see that that is Fremont Avenue, and that's Girard Avenue and Humboldt Avenue. I can tell that that's 37th Avenue right there. So this is a really good example to get started with. And for the sort of best case scenario, I'm going to focus on this one right here. Now, one thing I just want to mention is when you're looking at these black and white scans, it can be hard to tell which numbers are the enumeration district numbers, right? There's a 9 here, there's a 10 here, there's a 307 there, there's an 8 there. What you want to be looking for usually are the ones that look like they were written in pencil, right? Those are usually the enumeration district numbers. If that's not obvious to you, you may have to turn to the manuscript descriptions, right? So go to the Steve Morse website, look up those descriptions of the area, and I'm about to do that for you now. So if I'm looking for enumeration district 307, I'm going to click on view. So I can also verify that 307 is the enumeration district number there by looking at the information that they provided in the manuscript description about what streets will be found in this enumeration district. So you kind of have to cross-reference multiple materials sometimes to make sure that you're using the right identifiers and you're in the right place. Another thing that makes this a best case scenario is that when you're in central cities, you'll usually see, pull the image back up, you'll usually see numbers on the blocks. You see if I scroll in real close, block 7, block 6, block 5. In the manuscript descriptions, they will tell you which blocks you're going to find within those boundaries. So in enumeration district 89307, you're going to find blocks 1, 2, 3, 14, 15, 16, 17, 18. This is a really nice clean case. It's one of the easiest that you will encounter. But if you're just not even sure on that count, you can also see what streets bound each block, right? So there are lots of ways to check your work. So I know from looking at this image here that enumeration district 307 is bounded by 33rd Avenue down here, Bryant Avenue along the west, 38th Avenue along the north, and 6th Street along the east. Okay, sometimes you kind of have to move around because the labels will be somewhere else. So when I go to Minneapolis, there's Crystal Lake Cemetery right there. Lovely. And this is where I'm going to be working. I see 33rd Avenue right there. I see 6th Street right there. I'm going to zoom in a little closer. I see Bryant Avenue right here. 38th Avenue is also Dowling, and you can see that in the map here, right? It's Dowling and it's 38th Avenue. So a little confusing, but there's a way to check. All right, so I've kind of scoped out the area and where this enumeration district is going to be located. I'm going to zoom out a little bit just so you can see the whole thing. Now what I'm going to do is turn on that add polygon feature tool, the little blob with the star next to it. And I'm just going to pick a corner to start on. It's best to pick a corner. So I'm going to pick the corner of Dowling and Bryant, which is here. And I'm going to click, left click. And now you see I've got this red line kind of stuck to me, right? It's waiting for me to say where it's going next. I know that the northeast corner of this enumeration district is 6th Street and 38th, so I'm going to left click there. All right, and now you see it's making, it's sticking those points. And I'm going to zoom out. You can zoom in and out as you're working with this tool. It's not going to make you stop what you're doing. So if you need to readjust what's displayed on the screen, you can do that. And you can also, if you don't have a wheel, it really is nice to have a mouse with a wheel, but if you don't have one, it's okay to, even though you have this tool on and you're not done yet, it's okay to go back up to your map navigation tools and, click on the little hand to move the map around. So let's say I need to see down here where 33rd Avenue is. When you go back to your little new polygon feature tool, it's still there. You're not going to lose what you're doing if you need to go to your map navigation tools to readjust. All right, so I know I was traveling down 6th Street to 33rd Avenue. So here we go. And then finally, we want to go back to Bryant Avenue and make that nice, clean rectangle. And now that the whole shape is drawn, what I'm going to do is I'm going to right click. And here's what QGIS will do. It'll pull up those data fields that I asked it to create. And this is where I'm going to enter in the geographic information. So I believe, let me go back to my reference materials. If I look here, I'm in Hennepin County. The FIPS code for Hennepin is 27053. And I'm also just going to note that the prefix for Minneapolis City is 89. I need both of those things. 27053 for the FIPS. The prefix is 89. This was enumeration district 307. There are no parts. This was one single polygon, one single enumeration district. So I'm just going to say 0. There were no parts. And I have no notes, so I'm going to leave that blank. All right, because I had that label feature turned on, what's going to pop up here is 307. So now I know enumeration district 307 is mapped. There it is, nice and clean. Let's say when I was creating this, I'm just going to do something wacky here. Let's say I accidentally messed up and it looks like this, and I don't want it to look like that. You can go to your vertex tool. It kind of looks like almost like a bow and arrow. I always see it as bow and arrow. You can look at your vertex tool, turn that on, and when you hover over a shape, you'll see the vertices light up. just grab that vertex and drag it to where it's supposed to go. So you can always refine what you did after you did it. Right, no problem. Okay, nice clean example, no issues there. And it is geo-referenced, so these lines will always pop up along those streets and in those places. Another example that's a little more challenging is one that's right next to it, Enumeration District 309. So if we look at 309, I'm going to go here. 309, you'll see the pencil lines kind of going along here, along 33rd Avenue, traveling up, what is that? 2nd Street, and then 36, and then traveling up this little unlabeled street here, and then heading out to the Mississippi River. So one of its boundaries on the eastern side is the Mississippi River. It comes back down to Lowry, comes down here, over there, right? And I could check the manuscript description to make sure I'm actually seeing this correctly. But that is what it looks like. So there are a few challenges here. One, you've got unlabeled streets. Okay, so you got to do a little more legwork to figure out what exactly street that is. Another challenge is one of the boundaries is a natural feature. It's the river. I'm going to follow what the map says and just draw that line right down the middle of the river. And then something else you'll notice is that this is what this area looked like along the river in 1940. It doesn't exactly look like that now. There's been some development there, right? Probably some new facilities, new things were built there. So it's not quite the way it used to be. So I have to make some decisions about where things are. I may have to estimate where a street was supposed to be. But I'm going to do my best here to draw out this boundary real quick for you. It's never good to do these things quickly. What I'm going to show you though is, as I'm doing this, I'm going to start here because one of the vertices, we pull this back up, 309 shares a vertex with 307. See that corner there? It's also the corner of 307. So that's a good place to start because what I can do is when I create a new polygon, I can look for the vertex of 307 and what will turn on is that little pink icon. That's the snapping tool. It's showing you where you're going to snap to so that these two polygons are snapped together. So I'm going to start there. It's a good place to start. All right, so I know that this goes down to, let's see, that is 3rd Street. So here's an issue right here. 3rd Street, it looks like a school was built there at some point, but I can still kind of see what was left of it right here. And let's see, there. Okay, it travels down 3rd Street to 31st, or to, yes, to 31st. So I'm using my map navigation tools to kind of get to where 31st Street is. There it is. I'm gonna turn my drawing tool back on. Here's 31st. And then it travels over to Pacific, which is right here. Thankfully, part of Pacific Avenue is still there, right where I need it to be. And then it travels up to Lowry. And then we're in the middle of the Mississippi. This is the eastern boundary of the polygon. So for this part, there's no super precise way you need to do this. Nobody lives here anyways, right? It's the middle of the river. But I'm going to do my best to just kind of click along the shape of the Mississippi until I get up to where I need to be, which is, if I'm looking at the drawing, I need to go all the way up to 38th Avenue. So where Dowling is 38th. Okay, here we go. And then I'm going to travel just before the railroad. And here's a problem. I am here. I'm figuring out where to draw this vertex right here, this unnamed street along the railroad. Well, it's not really there anymore, right? You see there's West River Parkway is kind of running along there. So this is a case where I kind of just have to, guess where it used to be. And I'm going to do my best to stay faithful to where that street was until I get down to 36th Avenue, which is here. Okay, and then I need to go to 6, which is here. All right. I want you to remember this case right here, because this is going to cause problems for us here in a minute. All right, I've got the shape drawn. It wasn't the most fun example, but it shows you how complicated it can get. I'm going to right click, fill in my information real quick. 90309, no parts. Okay, I'm going to do one more, but first I want to show you something. I needed this to be a straight line coming out from Dowling Avenue. And notice I didn't quite get it right. It's kind of like slanting upwards into a northeastern direction. I don't really like that. I'm kind of a weird perfectionist about these things. So I'm just going to move that down just a little. It's still not great, but it's better. I'm going to draw 308 just because it's a really quick and easy one to draw. It's right here above 309. It just kind of closes that gap between 307 and 309 going along Dowling. So I'm just going to click, 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 click. All right. All right. So the reason why I did that is because now I want to show you how the geometry validation tool works. So up here is my topology checker. It's this weird blue blob with vertices and lines going everywhere. I'm going to open that tool and click on this little wrench. And what I want to tell it to do is to check for certain common issues that come up with geometries that are being drawn. I'm going to tell it on the Minneapolis layer, I don't want it to have duplicates. Add that rule. I don't want it to have gaps between the polygons. I don't want my polygons to overlap. And this is a less common one, but I don't want any invalid geometries. Sometimes weird things happen and you don't want them to happen. I'm going to say, okay, all my rules are in place. And now I'm going to hit this check mark. Whoop, see that red line there? There's an issue. What is the issue? I'm going to uncheck this little check mark here so that the line goes away and I can take a look at what the problem is. It's telling me something along this line is breaking one of my rules. So I'm going to uncheck here. And I'm going to zoom in real close. And look at that. What happened was when I was drawing these two shapes, there was no vertex on enumeration district 307 to snap to, because this was just one continuous line. And so what I need to do to fix this problem is make a vertex over here that these two guys can snap to. So how I can do that is I'm going to turn on the vertex tool. I'm going to hover over 307. And what I'm looking for is if I'm on that line, a little crosshatch should pop up. You see it right there. I'm going to zoom in real close. It doesn't make it bigger. There's a little hatch right there. It's an invitation to grab that and make a new vertex. So I'm going to grab it. And what I'm going to do is I'm going to drag it up to where the other two vertices are. There's my snapping tool turning on. And snap it. And then when I hit this check mark again, problems go away. Clean bill of health. No issues. All right. So we just mapped 3 enumeration districts in Minneapolis with no geometry, no invalid geometries, no gaps or overlaps, nicely labeled, nice clean lines. There are 2 other examples I want to walk through. I think I'll do the rural one first. So when you get out into rural areas, this is Anoka County. It's north of Minneapolis. Here you're dealing with really big, sparsely populated townships. Out here in these areas, and our prefix has changed because we're in a different place. The prefix is now 2. What I find when I go looking for enumeration district 210, let me go here. Just gonna save a little time here, go looking for Anoka. Here we go. When I go looking at 210, I'm just going to focus on this column here. Notice what it says about the description. It says 210 is just Centerville Township. When you get out to these rural areas, sometimes an entire township is an enumeration district because the enumerator could enumerate that township in in 2 weeks, right? It's not going to take longer than that. So the whole township gets counted as one. There's another enumeration district here if you're looking at the image, 211. On the description, that is Centerville Village. So there's Centerville Township, and then within the township is Centerville Village. Now, this is a slightly more challenging case because there's a polygon within a polygon. There are tools in QGIS to handle this. So I'm going to go back in here and I'm going to head up to Centerville, which is actually not called Centerville anymore. Where is it? This is always the fun part, figuring out where I am. Here we go. It's actually now called Lino Lakes, but the village of Centerville is still in here. I'm going to turn off my topology checker. So what's nice at this point with having OpenStreetMaps as a base layer is that if you look really closely, sometimes the township lines are still there. You see that dotted line going along this highway? That's actually the boundary of what used to be called Centerville Township. So that makes it really easy because all I have to do is trace that. Right here it is going down this way and going along the south here. All right. So I'm going to turn on my polygon, my new polygon tool, and I'm just going to grab that northwestern corner of Centerville Township and head that way. There is the southeastern corner and there is the southwestern corner. All right, so Anoka County's FIPS is back here. 3. County FIPS is 3, so we want 2703. The prefix here is 2, and this is enumeration district 210. There are no parts. All right, 210 is mapped. Cool. The problem is 211 is in 210. So what do we do about that? So first, I'm going to change the transparency on my layer so I can see the base map underneath. I'm going to move this. Oh, no, not you. Go to symbology. I'm going to move it all the way down to 30. Yeah, that's good. Okay. And then if I go up here, this is a nice case where the boundaries of Centerville are still pretty much the same. You can see that dotted line. Let me turn this off real quick. You can see the dotted lines of the Centerville Village right there, going around like that, up that way. So turning this layer back on, there is a tool up here called Fill Ring. What Fill Ring does, it operates a lot like the new polygon tool does. But what it allows you to do is to basically cut out a polygon within a polygon and give it new attributes. So I'm going to draw the Centerville Village, just following its dotted lines here. Down, down. Great. I'm being a little messy, but I can always fix that later. All right, there's Centerville Village, and just to show you, there it is right there. Right click, and it's gonna default to whatever enumeration district you just cut it out of. So you just need to change the information to match what this is supposed to be. This is actually 211. The village, not 211, sorry, 11. It is 11. And there we go. And because I made a mistake here, this is supposed to be 10, not 210. This is a good chance to show you how to edit attributes. So I'm going to right click on my layer and go to Open Attribute Table. It's going to bring you this. My editing is turned, whoops, no. My editing is turned on. Here where it says 210, it actually was supposed to say 10. So I'm going to change that real quick. And there we go. That fixed the problem. All right, one more example. I'm going to try to do this one really quick. there are situations where enumeration districts are split into parts. So I'm going to go back into Minneapolis because there's so many good examples in the city of Minneapolis. Sometimes you will see an enumeration district number with letters at the end, right? A, B. What I'm going to do is I'm going to go click on the microfilm for that. You'll get to the description and you'll see next to it AB. What is going on there? When I navigate to the next page, this is what's going on. Enumeration District 206 was split into two parts. And you need to map it that way because that's how the data will appear as well. And so the challenge is when you're only looking at the drawn maps, they don't draw out the parts for you. So here is 206. Here are the boundaries of 206, right? Going along here. Parts A and B are not drawn. And so you have to rely entirely on the written description to figure out how to split that area up. And it can be helpful if you have an editing tool. So I know Dr. Jalefka prefers to use a PDF editor. Brenda has Procreate, which allows her to draw on the allows them to draw on the images. I just use the Windows photo editor, and so I'm just going to hit edit here. And if I'm following the written description, zoom in real close here. What I can do is I can just turn on a pen. I'm going to turn on yellow. Here's 206 all together. Sorry for my terrible drawing skills. It's not great. All right. And then if I'm looking at the written description, I know that A is along these streets within the boundaries of 206. So going back to my little drawing here, if I'm following what it says, oops. A goes like this, up here like that, along that street. That's a terrible line there. It's supposed to go right here. And then B is here. So drawing it out ahead of time ensures that when I'm creating it in QGIS, I know where to draw those parts. And I'm just going to do one of them. This is another one by Cemetery. Makes it very easy to figure out where you are. Go back into Minneapolis here. Here's Lake Harriet. There's St. Mary Cemetery. All right. So if I'm looking at my little drawing here, I want to follow 48th Street along Cedar, along 51st Street, down 14th, up Chicago. So I'm going to move this over to my other screen so I can see what I'm doing. I'm just going to do the first part just in the interest of time. So if Chicago is my western boundary, part A is going to look like this, out to Cedar, down to 51st, over to Bloomington, up to Minnehaha Parkway. And here's a fun example of a nice curvy street where you've got to draw lots of vertices. And yes, I actually need that to go roughly here. And when I enter in the data for this one, this is 089, part 206. This was part A. We use numbers instead of letters, so we're going to say 1. And leave it at that. And then when I draw part B, want to make sure you snap every single one of those vertices along the way. So if you get a little too wild with the vertices and add a whole bunch of them, you might be punishing yourself later when you have to snap every single one of them. And just keep that in mind. All right, and there's part B. It's also enumeration district 206, but it is part 2. I'm going to make sure I caught all those vertices. I did. No errors are coming up in my topology checker. If I had missed a vertex, it would have shown up as a gap or an overlap, but somehow I managed to catch them all. Okay, I want to go ahead and save my work so that way I can pause and ask you if you have any questions, and discuss any other things you might have on your mind when you're doing this kind of work. So here are 2 things you want to do when you're wrapping up your work or you're pausing for the day. One is when you look at your layers panel, the pencil here is red. If it's red, that means that your work is not saved yet. So you just want to right click and say save layer edits. And really, you should try to do that like every 10 or 15 minutes or so, because QGIS can bug out. Like it can do weird things. You can lose your work. I use Google Drive as my working drive. And so sometimes Google Drive disconnects and then I lose everything. It's not a great way to work, but I don't seem to want to learn. So make sure you're always saving your work. And then you also want to save your project because your project has all your environment settings. And so when you load up your project, all the layers will be there, all the settings will be in place. You'll even start right where you left off in terms of what's being displayed. So for that, you just go through your normal save as process. And I'm going to put it, let's see, I want to be here. I'm going to put it in just my main project folder, and I'm just going to name it Minneapolis, St. Paul, 1940. And this is saving as a QGS file. That is a QGIS project file. And at this point, I could close everything out. And if I wanted to go back into my project later, I can just load up the project file and it'll bring the environment back exactly the way it was. If you instead want to load up a shape file, there are, I told you all the other files that pop up too, there they all are together, right? So you always want to keep those files together. Okay, so that was a very step-by-step hands-on demonstration. And I know it was, again, a lot very quickly, but that's okay because the purpose of this was to walk you through some of the more common scenarios. So that way, when you're doing your own work later, you can go back and say, how did she do that again? And it's right there. So with the little bit of time that we have left, I'd like to open it up for any questions y'all have, anything you want me to revisit. Let's go ahead and do that. You can use your mic or you can use the chat. Okay, that's a good question. So Michael asked what the experience is like when multiple people are working on a project together. Brenda and Patricia can actually speak to that because they are mapping Los Angeles together. So what are some of the strategies that y'all adopt to make sure you're not overlapping each other's work?
I can start. So there we have all of everything is in the shared G Drive, Google Drive. So that's really helpful. But we split up the maps. So there's 56 maps and then we kind of split them down the middle. And then there's it's almost 2,000 enumeration districts that we're going through and kind of matching up to the maps. So we both kind of have the Google Sheets going and they're not in order, which is why it's not like you can just divide the Google Sheet just like in half. So it's really important to be really organized about all of the data that you have and that it's like filed correctly and that there's clear delegation so then that people know what they're working on and when. Yeah, so that was a good like learning lesson and like it's like map based for us because there's like a map and then there's all the enumeration districts in the Google Sheet. So then those are like highlighted green as we're working on them. Yeah, that's what we do. They are sent to Dr. Crowell and they're merged later.
Yeah, so later what my job is to seam them together, and that involves relying heavily on the topology checker to show me where the gaps and overlaps are, and then I can repair those boundaries. Yeah, any other questions?
Can you show us how the geometry checker works?
The one that I was using?
Yeah.
Yeah, so I prefer the topology checker. The geometry checker, Dr. Jalefka, do you ever use a geometry checker? Yeah,
No.
the geometry checker can cause you some grief because it won't let you leave your work until you fix the problems. So we all kind of avoid it because we feel like it's a little too nagging. But the topology checker, I think, is quite effective at just like periodically checking your work and fixing boundaries. So
Then
I
maybe
can,
show how that one works.
yeah.
Stay away
So I
from
can
geometry.
go. So I'm going to, let's see, I'm going to break something. Let's see, I'm just gonna grab, nope. They're snapped together, and so I need to kind of delete. I'm trying to break something so that way I can show you what can happen. All right, I just made a giant gap there. And I'm gonna do an overlapping example. So I'm gonna grab a vertex and throw it down here. All right, so when I hover over this area, there's a vertex that's just gone rogue, right? It's like way down here, it's going way into the other space. Like that's a problem. We don't want that to happen because then when you're mapping your data, you're gonna have this like wild overlap. It's not good. So on my topology checker, it's this little icon here. You want to make sure the plugin is installed and turned on. First, you want to make sure that you've set your rules, right? So on the Minneapolis layer, you want to add all the rules that you want it to check for, right? I don't want gaps. I don't want duplicates. I don't want invalid geometries. I don't want things overlapping. Those are all turned on. And then I'm going to hit the check mark and it's going to check the whole layer. And when I hit the check mark to run the checker, whoa, look at that. It lit up super red because this is a problem. It's telling me exactly where something went wrong. And it's telling me it's an overlap issue, right? This polygon is overlapping this one because of this vertex right here. So I'm going to use my vertex tool to just grab that rogue vertex and move it up here. Let's turn this off. Move it up here and snap it to the vertex for the polygon right below it. So that way it is playing nicely with it. And when I check again, that error goes away from the error report. Your goal is to have it say 0 errors were found. That's the goal. Every once in a while, you'll come across an error where you can't seem to fix it. And it doesn't always happen. It's very rare that that happens, but sometimes I just delete the polygon and draw it again. It's like, I don't know what's wrong with it. I don't know what you're reacting to. I just delete it and draw the polygon again. That's an option too. If you ever want to delete a polygon, you're going to use your selection tools up here. And so you're going to want to grab this button. So select features by area single click. And I'm going to say select 206. Let's say I don't like the way I drew that. Okay. I don't want to deselect. Go to the trash can over here. It says delete selected. It's going to say, are you sure? I'm going to say yes. There it goes. If you did that by accident, you can always Control Z and bring it back. There is an undo button that works most of the time. Any other questions? I'm not sure if I missed anything in the chat. Let's see.
I also wanted to add to Heather Bloom's question if georeferencing would be easier. I also want to name that some of the scans of the maps, not the microfilm maps, there are other maps that are available also in PDF form that you download, but they're scanned from a book. So they're curved like inherently from how they were scanned to be made available. And it becomes quite difficult. You have to kind of guesstimate to be able to insert it to either ArcGIS Pro or QGIS. So it becomes quite difficult and quite time consuming to input those maps to georeference to do it. And it's quicker to just kind of like northwest or northeast, what are the boundaries? So that's something that I also thought about, and something to keep in mind, like the curvature of the scans that are available for certain maps.
Yeah, some folks on our team, like Brenda, has tried it. I think Patricia, were you doing it too?
Yes, I was trying it also, but the more I tried to manipulate the image, it did something to where it was too manipulated, and you couldn't even tell what was where. So
Yeah. It's definitely if all the stars align, it can be like Dr. Jalefka said, a really handy time-saving option. So there's definitely no reason not to do it if you have the materials are the right quality that you need. If you want to introduce beginner students to GIS, if you have the time, you can definitely teach them georeferencing as well with those materials. But there's also a way to do it without.